You know, it's pretty wild to think that some of the most beautiful parks you might walk through are actually built on top of literal mountains of our old trash. It's true, and it's all possible because of the incredible and kind of surprising science of the modern landfill. So today, we're going to peel back the layers on these hidden structures and reveal the fascinating engineered world right under our feet.
All right, let's get right into it. First things first, we need to totally redefine what we're talking about here, because a modern, engineered landfill it's a completely different universe from the old school dumps you might be picturing.
I mean, think about it. It's such a simple question, right? But the answer is unbelievably complex. Every single time we toss something in the bin, it starts this whole journey that ends up in one of these massive, super carefully managed sites. A way isn't some magical void. It's a real place, and how we build that place matters a lot.
And this right here, this really puts it all into perspective. On the left, you've got the classic open dump. Just a mess, right? Unplanned, unsanitary, basically a recipe for an environmental disaster. But on the right, that's the modern sanitary landfill. It's an engineered solution designed from the ground up specifically to protect our environment.
So here's the official take on it from a Purdue University study. And you got to pay attention to a couple of key phrases here. Without creating nuisances or hazards, and the big one, utilizing the principles of engineering. See, this isn't about just hiding trash anymore. It's about containing it scientifically.
Okay, so how in the world do you actually build one of these things? Well, it's not as simple as just digging a big hole. Nope. It all starts with an incredibly detailed blueprint and a whole lot of science.
First off, you can't just plop one of these down anywhere. Picking the spot is this massive decision with consequences that will last for decades. Engineers have to look at everything on this list. What's the geology like? What kind of soil are we working with? And maybe most important of all, what is the risk to our water supply? They aren't just planning for next week. They're mapping out the entire useful life of the site, thinking way, way into the future.
This is so cool. This shows how engineers basically find the perfect recipe for a stable landfill. It's kind of like baking a cake, you know? You need exactly the right amount of water in your ingredients. If the soil is too dry, it's like trying to pack down flour. It just won't work. But if it's too wet, you get a weak, muddy mess. This graph helps them find that perfect sweet spot to create a rock-solid foundation for everything that's going to be built on top of it. And this is where the design gets really, really clever. This is something called the Fukuoka method. It's a special design that actually helps the waste break down faster and, more importantly, safer. It uses this whole system of pipes and vents to get air circulating and to drain away this nasty toxic liquid that's called leachate. Now, this design is absolutely crucial for a successful landfill because, as we're about to see, if these high-tech systems aren't maintained perfectly, well, things can go very wrong very fast.
So, the site is selected, the design is all set. What actually happens on a day-to-day basis? It turns out it's a highly controlled, really precise cycle.
Every single day, it is the same exact routine. The trucks come in and dump the waste at what they call the working face. Then these huge, heavy machines spread it all out into thin layers and just drive over it again and again and again to compact it down. And then, here's the crucial final step. At the end of every day, the waste gets completely covered with a layer of soil. That daily cover is what stops the smell, keeps pests away, and prevents trash from blowing everywhere. So really, the whole operation comes down to two words: compaction and containment. Everything in that daily cycle we just saw is designed to do one of two things: make the waste as small and dense as humanly possible, and then keep it safely locked away from the outside world. And here's what it looks like when it all comes together. Each one of those daily layers of compacted waste and soil forms what's called a cell. Over months and years, these cells get stacked next to and on top of each other, almost like gigantic building blocks. The whole thing is held in place by those sloped embankments you see, creating one massive, stable, carefully constructed mound.
Okay, so we've seen how it's supposed to work. But what happens when that careful engineering, that precise daily routine, just breaks down? We're going to look at a case study where a state-of-the-art facility was pushed to the brink of disaster. So, let's talk about the Kurizak landfill in Tehran. On paper, this place was modern, it was engineered, it was even based on that advanced Fukuoka design we just looked at. But a whole chain reaction of what seemed like small operational failures ended up creating a massive, massive problem. So here's the play-by-play. First, the gas vents got broken by some equipment which stopped the air from flowing. Then, the daily soil covers they were using were too dense, they were almost waterproof. This basically turned the landfill into a giant bathtub with no drain, trapping all of that toxic leachate inside. With nowhere to go, the liquid just built up and up until it started seeping out through the sidewalls, soaking the very soil that was supposed to be holding the entire structure together.
Wow. I mean, the contrast here is just staggering, isn't it? On the left, you see the clean, perfectly engineered drainage system when it was being built, and on the right, that's the result of the failures. Toxic, black leachate just pouring out of the walls, contaminating everything around it.
And this table right here shows just how bad the damage was. That friction angle. That's just a technical way of saying how stable the soil is. Look at those numbers. The clean soil has a stability of 38.5 degrees. But once it was contaminated with leachate, it dropped to just 7.8. The leachate basically turned the strong, supportive soil walls from a solid foundation into weak, unstable mush.
And this is the final, chilling verdict from the researchers who studied the whole thing. They concluded that the landfill had become so dangerously unstable that a major earthquake, which is a known risk in that area, would have caused a complete, catastrophic collapse. The engineering failed, and it created a ticking time bomb.
But let's end on a more positive note. Because when a landfill is managed correctly, its story doesn't end in disaster. In fact, when it's finally full, it gets a whole second life. A new, carefully engineered transformation.
You see, closing a landfill isn't about just locking the gate and walking away. The post-closure phase is just as scientific as its construction. The entire site is capped with special layers of clay and soil, and it's monitored for decades to make sure it stays stable and safe as all the waste inside slowly settles and decomposes.
And this is where the really cool part happens. After all that careful engineering, the land can be given back to the community. So many former landfills are now beautiful public parks, golf courses, sports fields, even wildlife conservation areas. It's an amazing testament to how science can literally turn our trash into a community treasure.
So we've seen the incredible, complex engineering that goes into managing everything we throw away. These landfills are the final, complex solution to our consumption. And it kind of leaves you with a big question, doesn't it? If this is the very last stop for our waste, what could we change at the very first step to maybe lessen the burden on these amazing engineered marvels?